Just so
Well, I
you know,
welcome everybody to um, our latest in our 2 years, actually, of monthly programs sponsored by the New Jersey 50 by 30 Building Electrification Team. My name is Steve Miller, and my wife Pat Miller is on here helping with admissions, and we have a series of other people as well. I help round up all of our great speakers, and one of the greatest ones is tonight. But before that, a complaint from a previous meeting was not to include an explanation of the benefits of the IRA Inflation Reduction Act. It provides funding and helps fund our building electrification. And we covered the IRA, in fact, in May in building electrification program. Uh, we're we've created a new IRA presentation that will be trialed this weekend from two private uh, engagements and some others that are lined up. But a proposal would be, if that's still of interest, we could do that in the October 19th, the next webinar. And if anybody has an objection, I think we'll probably try to do that, at least maybe 20 minutes worth. In the meantime, what I have tonight in the next few minutes is an introduction to the IRA. And I wanted to share with you, I need to share screen. Here we go. All right. And so now I'm sharing the screen of a, and this screen share, actually, the URL is in chat for those people who joined us before I put it in. Pat, maybe you could just copy and generate it again.
Oh, okay.
So that the people who joined since will be able to see it. I'm pleased with this references. It's 400 some references to all things building electrification, and it has a big section on the IRA and how it helps building electrification. It has many other topics on the topics of building electrification, heat pumps, and building decarbonization.
I put that reference in the chat.
Okay, that's great. So one of the this is a little index. I actually just probably several hundred pages in various websites that I maintain, but this is one of my key things for this sort of index, plus all these others. And tonight we're going to talk about impact of IRA. The webinar tonight, in fact, will be recorded and put into this webinar index that will show all these previous webinars as well. So let me take you to the impact of the IRA, and we'll spend probably about 6 minutes on this, not very long. So I'm going to start with the top 3 things on here, just briefly. We'll look at them. The first one is something I really love, which is this put out by NRDC, showing all the components in a house. This is all the major sources of greenhouse gas, carbon emissions, in a typical New Jersey house. In New Jersey, the #1 source of greenhouse gas is transportation. It's close to half, in fact, of the total in New Jersey. And hence, it's important to get your car electric, or at least hybrid, and have a way to plug it into increasingly green, clean electricity. And the #2 source of greenhouse gas are the buildings. It's responsible for fully 1/4 of all total New Jersey greenhouse gas emissions. And because New Jersey residents, 80% of residences have gas furnaces and gas hot water, it's important to electrify those things. And within this type of typical house, you have other things that are gas, like you have gas dryers and gas stoves and range top, etc. The nice thing is, if you can electrify everything and you put a solar system on top that handles the yearly load for the house, then you have effectively zeroed out your home carbon emissions. Magic. And this is what some of our people, and you'll hear about this, I think, in November, somebody who has actually done that, continues to do that. As he adds cars, he adds more solar, and he keeps himself zero. So one thing important is that the house be well insulated. So the #2 thing on here is the top and bottom insulation, plus on all outside surfaces. Many houses that have been built in the dark ages quite a while ago are not fully insulated, and they have a problem because they leak a lot. They have holes in them for they leak in air, and they have poor insulation and whatnot. I wanted to take you back to a table here that summarizes, if it comes up, here we go. I am very pleased with this table. It's on 2 pages, and it's one table summarizing all of the IRA benefits applying to building electrification. And just taking you across, we have the topic on the left. We have in New Jersey, the biggest utilities are JCP&L and PSNG, and this lists the rebates provided right now. There's several other smaller utilities, and they're linked up here in this hyperlink. Everything you see here is live. So when you go to this, you can actually click things and see it. The next column is the IRA tax credit that actually is available right now and provides 30% of many expenses with a cap of $3,200 per year. But the last 2 columns are magical. If you have an income of your household, less than 80% of the area median income for your area, the IRA rebates cover 100% of all of these expenses you could, all over here, that you could incur in electrifying your house. That's great. If you're in probably the majority of us on this call tonight, up to 150% of area median income, this IRA pays 50% of all these things. That is super as well. Those are really great things. Now, how do you know if you're qualified? Well, what you do is go down here and you can look up your area median income for your area and then calculate it. And another really, really good thing is this Rewiring America IRA calculator. It's been out for, I don't know, a year or so. I've used it so many times. Go here, put in your income and your location. It does a calculation, tells you exactly what rebates and tax credits are available for you. So it's really a good deal. Now, on the left side are all the different things applying those numbers on that last cutaway drawing of the house correspond to these categories over here. And one of the very important things in New Jersey is because we get very cold periods, you have to have the heating system keep up that. We have utilities provide free and low-cost energy audits. And if they don't do it themselves, they give you a list of authorized weatherization companies. And not only that, they fund you for 0% loan for everything you buy and weatherization as well for up to 10 years. It's just a marvelous thing. And the other big thing that is done in New Jersey, unless I think it's true in most other states, is a home performance with Energy Star. If the company does the energy efficiency audit and says, well, I can give you in my case, 28% reduction in my emissions or heat loss, I got a $5,000 rebate on my bill. So that's a marvelous thing. Now, the bad thing is it's going to discontinue sometime in 24 and be replaced by these other products that are modeled and measured energy efficiency products with their own set. Each has its own set of requirements. So I think I've covered everything I want now for a high level. It's all summarized in this chart, really. And I keep inviting at the bottom. It says, if you think there are mistakes in this, let me know. Or if you think you can do a better job of summarizing, do it and let me know. So that's a good chart. So I'm pleased with it. And that's all of my time. And so now I wanted to turn the program over. It's for the 3rd consecutive month to our popular host, Sean Armstrong, who's the featured attraction of the Ask Sean show. And we introduced Sean. Go ahead, Sean. You've taken over my screen.
Hey, everybody. Okay, so thank you so much, Steve. I'd happily answer questions, as can Steve, about any Inflation Reduction Act stuff. The main things that are available right now are the tax credits, as he's speaking to. So tonight we're going to go through Kristen's house. And on the right-hand side, one of the things that's a theme of this show is how to not replace everything that's in red in this image. This is called your electrical service. And what you have is wires that are in red at the top, right? And then there's this tube, it's also called the weatherhead, that comes down. And then there's boxes that hold the blue thing, that's your meter, but you own the red boxes. All of this costs somewhere between $3,000 and $30,000 to replace, depending on if it has to go underground or up long distances. But it's definitely $3,000. And it takes 2 months to 18 months to replace in time. So you're going to see as I go through this presentation, I'm going to be focusing people on how to stay within the existing amount of power that's delivered to you by the utility so that you don't have to replace everything in red there for great expense and a lot of time. Okay, so just setting a little level set. What I'm trying to do is help you guys do a cheap and easy version of electrifying. So we're going to start with Kristen's house. This is her house, nice little brick house, New Jersey. Then next, this is her panel, and she has a really nice sticker on it that says the main. Okay, so I did a blow up on it, and you can see it says 100 on it. Can you all see that? The black switch here. This is the main,
Yes.
the main circuit breaker for the house. This is a circuit, is a loop of wire that electricity goes through, and this breaks it. It's a breaker. But what this is telling you is that you have 100 amps of electricity being delivered to your house, and it's always delivered at 240 volts. So you have 100 amps, and this is enough for houses ever since 1962, when the movement for all electric construction started in the 1950s. Utilities chipped in, eventually got to more than 2,000 utilities. We're trying to teach people how to electrify their homes. This is back when nuclear power was the new clean energy. So in 1962, the National Electrical Code has changed so that every house had to have 100 amps to start off with, which is enough for an all-electric home. So we'll just start with that. This is enough. You don't have to do an upsized service that I was just showing you. But still, you might want to be thoughtful. This is Kristen's air conditioner. The recommendation is that we're going to put in a reversible air conditioner. People also call that a heat pump, but it is a reversible air conditioner. It is an air conditioner, the exact same technology, and it looks the exact same way. Now, you can put in a carrier that looks just like this. I'm going to show you a picture in a couple minutes. It's a slightly different form factor, but it's the same thing. It's a big fan. That's what these boxes basically hold, is a really big fan. And then they've got a little bit of liquid in there that's called refrigerant that can boil at -50 Fahrenheit. And so it can always absorb heat from the environment. That's basically what it is, a big fan with a little bit of liquid in there. So you can put in something that looks exactly like that, exactly there, and then just replace the chunk of metal that's up in the attic, which is here. You can see that basically the instructions, how would you do this? You remove the black and white exhaust tubes. Okay, this is for gas combustion. You get rid of those things, don't need them anymore. Whoopsie. Now, it looks to me like this device here on the right, I think, is the gas furnace. It's all just one big gray box. And you're going to replace that gray box with a new gray box. That's the take home. And one of the things to note is that when you sent us a photo of the depth of your insulation, it looks like you have about a 2x6, like you have the same amount of insulation that people would normally have in the wall, which is about 6 inches of insulation. And up in roofs, or attics, I should say, up in the attic, people usually have twice as much as that. They'll have a second layer of that, and it helps keep the house warmer. And so that'd be a recommendation, is if you could, go get another one of these R19 bats, that's 6-inch bats, the ones that fill 6 inches of space, and see if you could layer another layer on. If you could, that'll make your house warmer.
Thank you. I had the sense that I think that might be the original insulation or something. Looks
Yeah.
help.
How old is your house?
I think it's a 1953, if I'm not mistaken.
This is probably new insulation because it would look a lot worse. And
Okay.
in the 1950s, people often didn't even insulate their houses, or if they did, they used things like shredded newspaper, not very good stuff. Like you could still read the newspaper kind of thing. They were working on that one, unless they used cork. Cork is a very old insulative material, but most people didn't build with cork. So you saw that gray box here, right? There's your gray box that has the air conditioner and the furnace in it. This is what your gray box would look like. Same thing, pretty much. You'd go in the exact same place. It would hook up into the exact same ductwork that you have. And the recommendation is that you get a 3-ton. A ton is referring to a ton of ice, and the amount of cooling that a ton of ice does when it's at 32 degrees Fahrenheit in a pool of water over the course of an hour. It's a very old metric based upon back when we used to use literally tons of ice to cool buildings, like we'd store ice and we'd use a ton of it. So that very old metric is still used. It's called 12,000 BTUs an hour, and that means 1 ton. If you tell your HVAC installer, look, I had consultants come, we looked at the house, I want a 3-ton heat pump. And they're gonna say, are you sure you don't want a bigger one? And you're gonna say, I want a 3-ton heat pump, please. Because every ton is $5,000. So every ton that they come through, then they say, you need a 4-ton. What they're really saying is, you should pay me another $5,000, please. And they say, like, how about a 5-ton? You'll feel better with a 5-ton. It's like, yeah, you'll feel better with like orthodontic braces on your children's teeth. Also, I know, I get this, James. Like, don't do that. You need a 3-ton. Sorry, my cat would like it. Okay. So now on the bottom, I mentioned how this is an air conditioner that now works in reverse. Okay, so one thing to note though is that you have your ducts up in your attic. And your attic is not, and so that means what you're doing is you're heating your attic in the wintertime and you're chilling your attic in the summertime. It's not that you could fix that. That's where your ducts are. You could do more duct sealing is the thing, because the 3-ton heat pump is good enough almost all year, but there's going to be some cold nights when your house is going to get a little bit cooler because you're losing heat up in your attic. And it's pretty cheap to have someone come up and put duct tape around each of the seals, but that'd be one of the ways, and it's particularly true at the registers. Your heat blows down from the ceiling, right, through registers.
Okay.
And usually what happens is that right at that spot where the ductwork connects to the little grill that's up in your ceiling, right where the duct connects to that, it's often loose and it blows a lot of heat into the attic. So that's a great place to just put some tape. There's a specific kind of duct tape, and it's not what we call duct tape. It's that's the old-fashioned duct tape. Nowadays they use something that's got more like a metal flashing look to it. But that would be ideal for you. To do a little bit more air sealing, a little bit more insulation to make your house a little more comfortable. And those two things, putting R19, just extra bats up on the ceiling, that's cheap. Going around doing taping of things, that's cheap. That's like in the hundreds of dollars as opposed to thousands of dollars category. And if you could do some of that extra insulation and do some of that duct sealing, you'll never be cold in the wintertime because you're just right at the edge of it being perfect.
I am a lot cold, so in here. Thank you.
So then, I wanted to introduce you to, like, there are different efficiencies of heat pumps. So in orange, this is the heating efficiency. And in blue, that's the air conditioning efficiency. You have this. You have the worst kind over here on the far left-hand corner. So yours is like a SEER 14 or so, maybe SEER 13. It's kind of older. When you put in a heating system for your house, you're not going to be able to buy something that's less than an 18 SEER, because it's the 10 here is the space heating system, and these are the ones that go down to cold temperatures. That when their efficiency is a 10 or 11 or a 13 or a 14, that's the kind that you need for space heating in the winter. And they automatically come with a SEER 18 or 20 or 24, etc. air conditioning. So one of the good things about this is that when you replace your air conditioner and you put a heat pump right there, and you run the same refrigerant line up into the attic that's there now, same refrigerant line, but now it's going to do both heating and cooling with that refrigerant line, you're going to have your air conditioning bills go down in the summer. And I want to show you an example of what this looks like. This is 700 houses that got what they call cold climate heat pumps installed. And a cold climate heat pump, as I said, is like it's a 10, 11, a 13, a 14. It's one of those metrics. It's not going to be an 8. Those have electric resistance backup. They don't work in heat pump mode when it's cold. That's not what you want. You want it to stay as a heat pump because it'll use half or 1/3 as much electricity in the wintertime that way, or even better. But here, in orange, this is what the air conditioning energy use was over the course of a day, and it would peak in Sacramento at about 4 in the afternoon. So people, this is when air conditioning was happening before. When they put in a cold climate heat pump, a reversible air conditioner that works in the wintertime, their air conditioning bills all dropped from 3.9 kW, which is a power amount, down to 3.4 kW. So it was like 15% less energy that they were using for their whole house, not just their air conditioning. The whole house overall is 15% less just because the air conditioner was a better air conditioner. And in the wintertime, it did make a new peak, which is this blue, because now you're using electricity in the wintertime. If I could show you gas, but this is all in electricity that you're seeing here. So you see that you're making a new bump in the wintertime of power demand because you're heating up in the morning time. People usually turn on their heater around like 6 in the morning, 5 in the morning. But it's smaller than your air conditioning peak in the summertime, 3.4 versus 3.3. So it's a little bit smaller than the peak, and it's a lot smaller than the old peak. This all has to do with your electricity bills. You actually will have lower electricity bills after you electrify, usually. It's not always the case, but usually because of this, you'll use less electricity in the summertime. This, I don't know if you've got a fireplace in your house, but I just wanted you to see that you can plug in these mist fireplaces if you do have one. And this one on the left-hand side, it's really fun. It's pretty affordable. It's like $1,400, not cheap, but it looks just like flame. And so you can like stick your hands in it, but it doesn't catch on fire. It's very entertaining for my daughter when I got one and she was 6 years old. It's like Harry Potter magic.
Can you put it in the existing fireplace, or it has to be built in? I do
Existing,
have a fireplace, but I never use it.
yeah, you can put it in the existing fireplace.
Okay, well,
It releases mist. What you do is like every day or 5, it depends how much you run it, but basically you can run it for a couple of days off of 1 liter of water. And you take out the little top, and there's an orange container in there, it's plastic, and you fill it up with water and you put it back in, and it silently makes flame. It's lit up with lights underneath, and it's mist coming out. It looks just like a fire. It's so convincing, better than any other fireplace other than being like a wood fireplace.
does it create heat?
Yeah, and you can also plug in heaters to them. They come with heaters if you want, so you can have like a hot fireplace that is.
Okay,
Then you just plug it in, 120 volt, any old outlet nearby, and it works.
thank you.
You have an electric resistance water heater, and you could plug in another heat pump water heater. There's also electricity, right? And it'll use about 1/3 as much electricity. Now, you don't have to. You have an electric water heater. It's electric. Good job. You did it. But you could use less energy with your next water heater if you wanted.
Okay.
And you could also, because it uses 30 amps of the 100 amps, you have 100 amp service. We talked about at the beginning. If you wanted to put in a really fast EV charger, you might, there's more than one way to do this. One of the ways is that you could, instead of having a 30 amp, instead of having 7,200 watts, you could have a 500 watt. Like watt on hair dryers. I'm trying to use the amount of power that we all kind of work with. So like a hair dryer is like 1,800 watts total. You could have a heat pump water here that uses 500 watts. And this is the one here on the left-hand side that you're seeing here. This is A.O. Smith and Rheem. This is a little Rheem here, but A.O. Smith also, they both make a tank that looks just like this that you can plug into any outlet. And this is using 500 to 900 watts as opposed to 7,200 watts. that this tank, your tank right now uses. So you use like whatever 3 times as much as a hairdryer or something. On the right hand side, these are heat pump water heaters also, but see this box here is big. It has a big fan in it. This is a heat pump that is for gigantic bathtubs. So if you have like like a 150-gallon eggshell bathtub, one of those truly massive bathtubs with maybe like jets in it and things like that, this is the water that you need. Oh, you don't have that? Okay.
I don't, but somebody else might.
Someone else might. So these are the ones, they're made in Japan specifically for like really big bathtubs. The ones on the left, this is for American showering. This is for America bathtubs, like a 30-gallon bathtub. This is just fine for that. I fill my bathtub, my 70-gallon bathtub. It's a clawfoot bathtub out on the back porch. I fill it with one of these tanks. I fill it with like 50 gallons of hot water, and that's great. But if you had a really big bathtub, you need the one on the right-hand side. And the important thing is that you could install this, not that your electric resistance water heater is nothing wrong with it per se, just this would use a lot less energy. And that same amount of energy could be freed up to go to a really fast EV charger, if that's what you want. I have a slow EV charger, it's fine. You already have everything that you need when it comes to your washer and dryer, and there's your water heater right next to it. That's adorable. And you could probably just keep it that way, honestly. Like this is fine, life can go on. Your stove on the left-hand side, that's a very lovely stove that I'm looking forward to getting rid of. So here you have an option in the middle. This is a KitchenAid. I like KitchenAids. I grew up on KitchenAid machines. I think they're great. But a KitchenAid is maybe like a $2,000 to $3,000 induction stove. Samsung is making a $1,300 induction stove, and Samsung is a great brand. Frigidaire is making a $1,000 induction stove. Not a great brand. And since it's the cheapest induction stove you could get is $1,000, anytime you buy the cheapest of something, like the very cheapest thing that's sold, it's not the best product, right? So you kind of get what you pay for when it comes to induction stoves. They start at $1,000. Samsung, which is a good brand, is about $1,300, and they go up from there.
Are you going to touch on this later? What has to happen with the hookup? Like, I need someone to correct the whatever happens behind the stove.
Yeah, you need a new wire run from your panel to where this, probably underneath your house, but maybe up in the attic if that's easier.
Okay.
The wire, it needs to be the same kind of wire that you'd have going to your electric dryer. It needs to be a 240 volt. It has a special like outlet on it. That's kind of 3 plugs, a little twisted looking. Yeah, you need a 50 amp circuit, and you'll plug in a 50 or 40 amp stove into that 50 amp circuit. It needs to be 240 volt. And that is kind of the only thing that's going to be tricky, I think, about your house, is just getting that wire installed. And I mean, spend about $500 for an electrician who's really skinny to crawl around underneath your house.
Okay. Thank you.
Yeah, it shouldn't be too hard. $500 of wiring, and then you can plug in your stove. Now, you showed us your bill. I thought that was very sweet of you to be honest. And you're like, look.
I know.
Very honest. So yeah, if an average home is blue and your home is an orange, and they're saying an efficient home is green, this is on gas. And this comes back to like, if you could add some more insulation to your attic, that would help out a little bit. If you could tighten the ducts, that could help out a little bit. But I wanted to show you this efficiency here. Go back to here. Another thing that you could do would be to get a more efficient heat pump. So once you get your attic as warm as you can get it, once you've done the work on your ducts, the next thing that you can do that's cheap is to get a more efficient heat pump, so it produces more heat with the same amount of energy. So you can keep your bills low. But so this thing like 10 HSPF, this is the heating seasonal performance factor. See that up there in orange? Heating seasonal performance factor, HSPF. And what you want, I think, is to get a 13 or a 14 if you could. Nothing like a 10 is okay, but really if you could get 11 or 12 or 13, like those HSPFs are going to be what helps you enjoy keeping your house warm on a budget. That's the efficiency you can do with the machine. Is get a more efficient heating seasonal performance. So Tom, when you were selecting Kristen's product, I see you've got a Mitsubishi. Did you choose an actual product for what its efficiency was when you were going through the products, or should we make a recommendation?
No, I didn't do any special selection, but I just picked a picture and turned it on its side to match the orientation. But that Mitsubishi unit I did pick can be mounted vertically or horizontally. And, and from looking at her attic pictures, we have figured out now the air is blowing from the right to the left across that furnace in the background. And then that left thing is the hot air duct, and that black hose to the far left is one of the room ducts coming out of it. So anyway, I think her next system can be simpler, and one of the suggestions I wrote in the text on the left side is to move the whole air handler a lot closer to the foreground of the picture in order to shorten the return duct, which is that real shiny thing on the right hand side, and in the foreground is the return duct coming up from the hallway. Just trying to get the ductwork all more compact so it's not losing so much heat or leaking so much air, and decrease the drag through it so that the new heat pump can move enough air to keep them comfortable. But it is, as you've mentioned already, kind of a two-pronged approach on using efficient equipment and upgrading the insulation and decreasing all the leakage that goes on both in the house and the duct system.
And that insulation and leakage, you'll say it again, is cheaper than getting a bigger heat pump. Like going from a 3-ton to a 4-ton, that staying at 3 tons and doing a little bit of insulation is a less expensive approach and takes up less space and all the rest of it too. So Kristen, when the time comes and you go get a bid from somebody, because ideally you want to get bids, send them to Tom and I. Okay, and we'll review them and try to give you some feedback, give you a little bit of white glove treatment.
Thank you. That's a really generous offer. Thank you.
Of course.
Yeah.
The right heat pump, the right efficiency, don't let anyone take your money. Okay, so we got your water heater, your dryer, your stove, the fact that you have a less efficient house, or you're just using a little bit more heat, whatever. You've got kids, you got to keep people warm. Now, I wanted to show you a few options for your EV charger. Let's say that you have an electric resistance water heater, as you do, and it's got a big 30 amp circuit. If you wanted to put in a NeoCharge where you plug your water heater into this same outlet that it is plugged in now, but it has essentially a plug strip where now you can plug your EV charger into the other side. So like, how a plug strip has multiple outlets on it? You do that essentially. It's this black box here, and instead of having like 5 outlets on it, it has just 2. But that way you can run your water heater, and when you're charging your EV, the water heater is not running unless the both of them are less than the total of 30 amps in the circuit. And then with NeoCharge, you can run both of them. They have this one called the Dryer Buddy because it's specifically for electric resistance dryers and other things. Simple switch, very similar idea. I just recommend the NeoCharge for your circumstance. You can buy them on Amazon. And so you could just plug your EV charger into that outlet. You might have to run a little cord from that closet to where your EV is, but that's what an electrician can do, is just run a cord. Some options that you might be less familiar with. Okay, so on the left-hand side here, see how it says connector? DER stands for Distributed Energy Resources, which is a fancy way of saying solar panels. So if you wanted to plug in a solar array, the cheap, easy way for you to do this would be to get one of these meter collars, is what they're called. And I showed you at the beginning how you owned all those red things except for the blue dot in the middle. Okay, that blue dot is the meter, and you can own this thing behind the meter, the connector, and plug in a really big solar array or a really fast EV charger. You say, how big? How fast? Well, usually, if you're going to your circuit breaker panel, this thing, 1 second, this thing here, usually you'd only be able to put a 4 kilowatt system up on the roof, which is close to the average in our country. 5 kilowatts is what a lot of people put up on the roof on average. So with a 100 amp panel, you can only put 4 kilowatts through it. But if you don't go through the panel, but instead you go behind the meter, you can put 15 kW, not 4, almost 4 times as much. So this is, the connector is just this collar here. You can see it, connector.com for installers. There's the link. So you can have as big of a solar array as you want up on the roof. I mean, 15 kW is a huge array. It takes about 2 kW to power a car for a year to make the amount of electricity that people on average drive. So if you had 2 cars in the house, you'd have 4 kW, and then you might have 5 or 6 kW for the house. So that's for everything. Like 10 kW is both cars and a house going. And this could you do up to 15. You could also plug a very fast charger into this, like a super fast charger. So this is a strategy to not have to play with the panel and the problems there and just connect straight into the service to your house. That's a neat strategy. Cheap and easy for some of those big ones. And I want to show you this, the same thing, this meter collar in the lower left-hand corner. PG&E gives them away for free now so that you can plug your F-150 Lightning into your house to charge your house when there's a power outage. PG&E has a lot of power outages, so they're giving these collars away for free and encouraging people to get the new electric F-150 because it has an inverter built into it and it makes just normal house electricity straight out the back of it, and you can literally plug it into your house to run your house off grid. So it's the same thing. It's this meter collar. I'm just trying to emphasize that this is a standard way to plug a lot of electricity into your house. 2 more things to show. Let's say, Kristen, that you wanted not only to electrify your house, but you also wanted a swimming pool in the backyard and a hot tub. That's a lot. You could do it, but you could put in a smart panel, meaning you plug all these things in more than 100 amps. You plug in 150 amps worth of stuff. Your house is probably never going to use 100 amps, no matter what you do, because that's the nature of people just don't have everything on at full blast all at once. But if you did go past 100 amps, this Lumen smart panel would shut off something, like shut off the swimming pool for an hour or 45 minutes, whatever, until the peak was over. So it's useful on Christmas and Thanksgiving, basically, because that's the days most energy. And there's bigger versions of that, Span and Genius, that can do even more devices plugged into it so that you never go past your 100 amps. You can plug 400 amps worth of stuff into this 100 amp panel this way. So, this is the last one. And flexible EV chargers. This is an EV home charger that can tell how much power you have available, and it'll just use as much as you have available. So it doesn't stress your house. It just is smart. It's like, oh, you have a lot of electricity. I'll charge fast. You don't have as much right now. I'll charge slow. That's very polite. It's a smart charger. And these are versions, by the way, on the right-hand side. They're coming out quickly where you can charge your house from your car. So Wallbox and Decibel's out, where if you didn't want to get a stationary battery for your house, stationary batteries are like 13 kilowatt hours and your car has 60 kilowatt hours. So if you have an electric car, you can use it as your house's battery if you want, and skip the whole big battery for your house. Okay. With that, I think I'll pause there. Do you have any questions, Kristen? Did like that go by a little fast for you? Do you want me to show you something?
I think I caught on a couple slides ago. I thought maybe I wasn't quite gathering what you're saying, but I don't recall the slide. Before the 2 recommendations you just made, the one right before that, prior to these.
collar, the collar.
These, yeah, so they're just additions that you can make to, which will allow you to use the same amount of amps that you already have and not add to it, but it will like disperse them as needed, something like that, right?
There's there's two places you can plug. Let's say it's a solar array. There's two places
Mhm.
to plug a solar array in. One is to the circuit breaker panel, which is, this thing at the beginning.
Mhm.
And you
Sure.
take one of the circuits at the bottom
Okay.
and two of them, and that's where the electricity would flow from the solar array in. But this thing here, all these little switches are designed to not catch your house on fire. So they flick over as soon as they get warm. And there's limits on the amount of electricity you can put in that often make it so that, well, basically on a 100 amp panel, this is a 100 amp panel, you could only put in a 20 amp circuit. And of that 20 amps, only 16 amps of the 100 could be used for the solar array. That's it. The 16 amps,
Okay.
that represents 4 kilowatts of solar panels up on the roof. That's how that works. So you have 4 kilowatts up on the roof, a 16 amp little switch here, and that's it. Or instead of plugging electricity into that panel with all its little switches, you plug it into the meter, this service box here, and all 100 amps is flowing into this spot. And it's not divided up into little switches. And you can plug all your power into it, or actually specifically about 60%. So about 60 amps, 100 amps can go into this connection spot. Yeah, Dan, you're putting in the chat there, Dan Longy. This is exactly the way to do it. Is you get this $500, $1,000 something device, and this is how you can plug a big solar array into the same 100 amp service. Now, Tom, you're trying to show us something there.
Yep, I'm showing, this is the meter socket that the meter usually plugs into. So it's like the left side of Sean's picture. And then that meter collar just plugs in there and then bypasses what's all, where all the circuit breakers are in the bottom of this picture. But I've just got my little prop electric panel that I use to help show people that, the different types of breakers there are and the different ways to connect more circuits to an existing panel.
So in this example, what we're saying is we're not going to plug it into the bottom of your device there, because that's all the circuit breakers. Instead, the collar is connecting more to the red chunk up there, the big pieces of metal. And the big pieces of metals don't get hot because they're big pieces of metal, and it's safer to put more electricity through them.
Thank you.
Yeah, you're welcome. I know it is technical, but
I don't mind it. I just no.
it's like you get this device and it's not well known, but it's a great idea. So you can put in your big solar array, and also you can put in a big fast car charger. 20 amps is what most people consider level 2 charging, and this can do 60 amps. So now you're up at something that people might call DC fast charging. Just scorching hot. To note, by the way, it's not good for your battery to charge it fast, because the hotter your battery gets, the less its life is, and the faster you put electricity into it, the hotter it gets. So a trickle charge, where you're charging it off of just an extension cord from someplace outside, that's the best place. That's the best way to keep your battery for 20 or 30 years in your car, as opposed to 15. Like if you just charge it slowly, that's what it likes for its long life, but you can charge it faster. It's okay. And Kristen, do you have any other questions before we take questions from the audience?
No, thank you so much. This has been excellent. Thank you. Can't thank you enough for your time.
Well, of course, and I hope you heard me say very earnestly, send us the bids that you get.
Okay. Yeah.
Tom and I, Tom does installations and I manage that kind of stuff too, and we'll give you back feedback and oh, that person's cheating you, or oh, that's a good deal.
That's awesome. You never know. Same thing with all kinds of service. They always wonder that.
I never
Thank you.
say they're cheating. I just say who it's a good deal for. I say, oh, I want to be that contractor.
Well, cool. Okay, so then Walter, Walter Kormacher, you asked to talk about heat pump dryers. Yeah, so let me bring up a slide here for a second. Because I have one on dryers. Where'd that go? Darn it. Okay, so heat pump dryers, just something to speak to. They are going to use about 1/3 the electricity that an electric resistance dryer would use. And that 1/3 electricity comes with them taking about twice as much time. So I'm gonna, one second, let me share my screen here. So these are three options that you kind of have. These are all 120 volt, by the way. So on the left-hand side, this is a heat pump dryer. A heat pump dryer means that inside of it, it is using very cold liquid and very hot liquid. It's basically, it takes heat out of the air that is moving and sucks it in and puts it back into the machine. And it's constantly pulling heat and moving heat to try to keep the air hot in there without it ever venting out. Like an electric resistance dryer heats up air, but then it blows it out the back of the machine. This instead squeezes water out. It's essentially a dehumidifier. And that squeezing of the water, the dehumidification of it is what drives your laundry. It does it at a much colder temperature. Electric resistance dryers, your clothing comes out kind of burnt, especially if you leave it in at the end, it's over dried and it gets kind of crispy, burnt. Heat pump dryers will never do that. They're just not as hot. So they take longer. Now in the middle here, this is an example of a 120 volt big electric resistance dryer. And it will only use as much energy as a hair dryer, 1800 watts. So this is a plug-in anywhere 120 volt device. And as an example, it takes about 3 times as long to dry laundry as a 7200 watt standard electric resistance dryer would, like what Kristen had in her house. So this is a slow as you go, the one in the middle. It's not as slow as the one on the left. The heat pump dryer will be faster, and these are both using the same amount of energy, just with different technologies inside. The heat pump sort of recycles the heat more than the resistance dryer in the middle, which just blows the heat out, and so it takes more energy. On the right-hand side is kind of the in-between spot. On the right-hand side, this is an electric resistance dryer that they call a condensing dryer. And it warms up air, but it doesn't blow it out the back. It brings it back, and it pushes the warm air against metal plates, and that just naturally chills it a little bit, and the water drips out, and then it heats the air back up. It's more efficient than electric resistance, but not nearly as efficient as a heat pump. There are 3 types. We have 3 types of dryers in our country. Heat pump uses the least, electric resistance uses the most, condensing, which is the in-between spot. One of the things I like about condensing drying machines is that they usually come with a washer, and that's nice because then you can just do a set it and forget it, a one and done. You put the laundry in, it's dirty, it washes it and dries it, and then it comes out clean and dry. I like that, personally. So condensing washer dryers is pretty much the only place you find that one and done strategy. But General Electric this summer has started offering their heat pump dryer and washer. So they have a washing machine that's combined with a dryer, but it's a heat pump dryer, not a condensing dryer. So it's kind of the perfect spot to get a heat pump dryer that's a combined product, in my opinion. And General Electric offers that. So now the question is, does that answer your question, Walter? Because you asked me to talk about them, but you didn't say, like, what do you want me to talk about them? Oh, Walter says, thanks. Good. It sounds like you got that. I was just noting, Michael Heller, you asked, does the collar limit what you can send to the grid if not using all solar generated? Does the collar limit what you can send to the grid? I think that it would have an internal circuit breaker of some sort for safety that would limit the electricity you can send to the grid, but usually you would design that. So I don't think you just sort of casually throw it. You'd make sure that it was fitting the specifications of the collar, which is to use 60 amps or less. I think 63 amps technically. And Tom, you said, I don't think the collar is limiting the flow in any direction or guiding it in any direction. It just gives a path to accommodate a larger flow of electricity. Shoshana, you asked, where do you buy a heat pump dryer? Home Depot, Lowe's, those two companies, they have them and they'll ship them to you. Your local appliance store might have them, but you know, they're always going to say, our distributor doesn't have them, or we only buy things that we think that people want. And you can go to your distributor and say, I would like you to get me a General Electric combined heat pump. You know, here's my product and such, that you got from Home Depot, searching through their searchable website, and you find the brand and such. It is a lot easier to get these advanced appliances online from our national distributors, I have found, than it is to get them locally, unfortunately. I mean, I try. I support local businesses. So John Wheeler, you asked, does she have a spot for a 50 amp breaker for the stove in her panel? Tom,
And yeah, I'm showing one right now that's, I don't know how visible it is, black on black, but the inner part of this one is 50 amps. It's two little levers, and you can see 50 on each of them. They're bonded together in a 2-pole 240 volt way, and the outer part is two 30 amp levers. And you can see when I push and pull that, the outers go together and the inners go together. So this takes up as much space as that 30 amp 2-pole breaker that Kristen already has in her panel for her water heater. So that's a way to get the space to slide the induction range right in there. Say I think she's down at the bottom left is the 30 amp in that picture. Yeah, I forget where I saw it. Let me just, zoning. Yeah, I see it. Bottom, yeah, almost bottom right is one, and then almost top left is another 30 amp. And so either one of those could be replaced with one of these that would let her get a 50 amp circuit in there. All of these breakers she's got in these pictures are standard full 1-inch width. And then just using these other breakers, like here, I'm holding a 1-inch width one that's got two different 20 amp levers on it. So it's a way to get two circuits handled on a breaker in the same space as her panel handles one. So
yeah, that's really important. Just a smaller breaker, so you don't have to replace that metal box. Not that it's a disaster to replace this box. This box costs $600 to $2,000 to replace. If you're in Silicon Valley, it might cost $4,000 in Silicon Valley, but that's like a whole other planet from normal pricing.
we're so lucky.
As a person who lives in Silicon Valley. Walter, you want to know, does that collar work with net metering? It does. Dana W, you asked, does a heat pump work in cold weather? I need to change my gas water heater. Thanks. A heat pump water heater works in cold weather, and some of them work in below freezing weather. I'm gonna make that distinction. So if your heat pump water heater is in your basement, or if your gas water heater is in your basement, if your basement doesn't get colder than 37 degrees in the winter time, then you can put your heat pump water heater in there also. But it'll turn off at about 37 degrees Fahrenheit. If your gas water heater is someplace else in your house, great. You know, stick it there. There are specific instructions for making sure there's enough air movement around them. So if you put it in a closet, you need to have a louvered door, pretty much is the rule. But the only thing to be aware of is, and water heaters aren't usually put in places where pipes freeze, right? Why would you put a water heater where you know that there's going to be a frozen pipe? So generally they're in basements and inside the house. Those are all perfectly fine places to put a heat pump water heater. And if it gets cold down there, it's like 37 degrees Fahrenheit. If you get an electric resistance backup model, then you have a second source of heat, even if it's just too cold down there to get your showers heated up fast enough. The electric resistance basically makes it go faster. It uses a lot of energy, but that's a strategy. But the upshot of it is that, yeah, people are putting heat pump water heaters in their basements in Michigan. I was just looking at a case study of 12 of them. That worked out great. People like them in their basements because they dry out the basement a little bit. They're a dehumidifier. So if you have a damp basement, and what basement isn't damp, it dries out the basement. That's a nice thing.
So thank you. So yeah, my water heater is in the basement. So do I need to measure the temperature in the winter to see if I can install the heat pump water heater? Actually, I don't quite really understand the theory why it works in the because some it's really recommended here. I live in New Jersey, so it can be very cold in the winter time. So
Well,
some yeah,
what-
some saying heat pump water heater is really energy efficient. I just don't. I'm trying to understand it better. Why is it energy efficient in the winter time?
okay. So
Thank you.
in the air in the wintertime, it's still warm, right? Everyone knows like 32 degrees is cold and 10 degrees Fahrenheit is colder and negative 20 is Fahrenheit is even colder, but it keeps on getting colder. We can go down to about negative 271 degrees Fahrenheit before there's no more heat. A heat pump, what it's doing, it's an air conditioner, either way, it collects heat that exists. It doesn't burn it. There's no burning to make the heat. The burning happened with the nuclear fusion at the sun. And the sun's radiation comes to our planet and warms up the air, also warms up the soil. And that's what you're collecting is the nuclear fusion energy. It's in the air. The air is warm. And a heat pump, which has a fan, basically collects air and it blows air against a liquid that wants to absorb heat, that will boil at very low temperatures. And so it can take the heat in. It is already very cold, and cold things absorb heat. So what they do is they have a fan that blows air. It's at some temperature. It has heat in it, some heat in it, and it blows that already warmed air over the cold refrigerant to absorb heat. And in that way, because you're collecting existing heat as opposed to making it from burning things, it's you don't have to use as much energy. You just have to power a fan and a pump that moves that super cold liquid around.
Okay, so when you say heat, but did you say it works better above 37 degree?
Yeah. So the refrigerants that are the liquid, that super cold refrigerant, it can go down to negative 40 in a water heater. That refrigerant goes down to about negative 40. But the home products that are used usually don't have a way of getting rid of ice that would build up on the coils as it got down into the 20s. So they don't let it get cold because they haven't installed a de-icing technology. Outside heat pumps for heating houses, they have that defrosting technology. And so they never let the coils outside get covered in ice. They always keep things warm enough in there. But the water heaters, those are kind of cheap. They don't have a fancy de-icing technology in them, usually. So instead, they just turn them off at 37 degrees Fahrenheit when it would start to accumulate ice on the coils inside with that cold refrigerant. So that's most water heaters, not all. And I just want to point this out. The water heater I'm talking about, this one here on the left, this tank type, this is the one which, as long as your basement stays above freezing, this is just fine. If your basement goes below freezing, you can get one of these, just one that has electric resistance backup. They're called a hybrid. And they're very common.
Hybrid. Okay.
Get a hybrid heat pump water heater, and the hybrid will will heat up the water even if it's 32 degrees or whatever in your basement, or 20 degrees. It just uses a coil. Electric resistance element heats up the water.
Okay. Is it okay to plug in like a small heater in the basement, in the furnace room? Is that safe to do?
Yes, it is.
It is?
Yeah. And
Okay.
it's not energy efficient, but it would be totally fine for some times in the winter. We always did that. I lived in rural Wisconsin, and our basement would freeze, and our gas on-demand water heater would freeze also. And so we kept a small electric resistance heater underneath the gas heater just so that it would not, all the little pipes in it wouldn't freeze.
I see.
Not ideal, but you just do it in the wintertime, you know.
Sure, sure, sure.
Yeah, but I
So,
think
mm,
you should get the
so
tank electric resistance backup in it, that hybrid that we're talking about. That
yeah, yeah, yeah.
if you're
Mm. So it's so if there's a ice, if not ice is not involved, then this technology can work in a much lower temperature. Did I understand right?
yeah. And
Okay.
on the right hand side, these water heaters that we're looking at, these
Mm.
have ice. So this says SANCO2, right? SAN CO2. This has this has an electric resistance element in it to keep the coils from freezing over. And so it's kind of like if you put a heater underneath your water heater, it's like, or put it in the furnace room, it's like that. But it has just like a little electric wire in there that keeps just that fan coil there. It's called a fan device, just that warm. So you can put heat pumps outside, not a problem. They just need to have de-icing in them, and most space heating heat pumps do. And just this water heater, like the Sanco 2 does, and most people would get these tank types and just put them someplace in the house where it stays warm enough, or they get a hybrid, and that will keep it warm year round because the electric resistance doesn't care what temperature it is.
The hybrid uses electricity and gas.
No, it uses two kinds of uses electricity for two reasons. It uses electricity in resistance mode, like a toaster element where the wire gets orange.
Sure.
Okay, so it has,
Mm.
that's not efficient, but it doesn't care what temperature it is outside. It just heats itself. Or you can use the air conditioner type, like that. That is the hybrid. Is that there's a heat pump, a reversible, and you can use electricity for that, or you can use electricity for electric resistance, and it's all programmed inside. You don't have to think about this.
I see. I see. So can I also add something to get instant hot water, like a circulation pump? So when I turn on the faucet, it's just hot water comes out instantly.
Yes, you can, but okay. So the right way to do that is a push button, so that when you want hot water, you push the button for it. That works great. But if you have it so that it's just always circulating, it makes it doesn't work as a heat pump anymore. Heat pumps don't work well with having hot water come back to them for a long period of time. They stop really working as a heat pump. So if you just push the button and it circulates the hot water around and then you use it, great. But you just don't want to have, and you don't want to have an occupancy sensor one. We've found that occupancy sensors, if like, they just run all the time also. So it's just a push button one. If you have a push button one, then that's perfect.
How do I put in the push button?
They cost like $600, and you have to get an electrician and a plumber basically to install the little electrical push button and a pump that's usually underneath the sink. And so you push the button, and then the pump will start moving water around. And then when you turn on the sink, the hot water will be there. But it's
What do you think of on-demand hot water heaters?
well, they use so much electricity. I'm assuming you're talking electric. So
Yes, of course. Yeah.
it's at least if you have 100 amps for that house, it'll take at least 60 amps to do an on-demand, whereas it would take like 5 amps if you do it with a heat pump. It's just radical how much electricity it takes to heat things up instantaneously or very quickly. And it's also true of gas. There's a huge gas flame in there in an instantaneous gas water heater. So it's just a huge amount of energy because water doesn't like to change its temperature. It takes a lot of energy to go into water to make it go up a degree and up a degree and up a degree. It's very hard to do. It's much better to like just slow and steady heat a tank of water with a heat pump. Or
there's a lot of sometimes I don't feel like waiting for the hot water to come, but and I understand Dana's question about
okay,
about the waiting for, wanting instant hot water. So
Well, let's
Anyway,
The-
I was just
yeah, the
wondering
name
about.
instant
yeah.
hot water heater is really a misnomer because the tankless water heaters, gas or electric, introduce a new delay in getting hot water because they've got a cold box sitting out there somewhere. And you turn on your water, the cold box has to sense, oh, there's water flowing. Should I turn on? Oh, okay, I'll turn on. And then it turns on and it starts heating the cold box up. Meanwhile, there's cold water flowing through. And if you had a tank water heater, when you turn on your water, hot water immediately leaves the tank and gets into the piping system on its way to you. It doesn't have to be heated. It was hot in the tank.
That's
I thought about putting a second hot water heater in closer to the bathroom so that it didn't take so long
That
to get
works.
there.
Yep.
Yeah.
this
Yeah, a
is
little couple gallon electric resistance storage water heater where that couple of gallons is already hot for you, and then the cold water mixes in with that, and so you get hot, 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 and then warm, warm, and then hot, hot, hot again.
so this is I have this to underneath my kitchen sink. I have a 2-gallon electric resistance tank. And it gives me, I keep it at the temperature that I like so I can turn on the hot water only. And it's just exactly the temperature of hot water I want. And I would suggest this. It is very easy to put a 1-gallon or 2-gallon tank underneath a bathroom sink or a kitchen sink. They don't take up that much space. And they only need a 120-volt outlet. So you can usually run the electricity just any old outlet nearby, or extend the circuit to that spot if you want to put a new outlet there. And then you don't have to do the recirculation pump, and this is probably cheaper. It's easier, and it is going to always work where you have the hot water immediately there underneath the sink, and it's not that big of a deal. You wouldn't want to do it for a shower necessarily. That's the big hot water load in the house. It'd be best if you could use your heat pump water heater, which is efficient.
So do you plumb this tiny 1 or 2 gallon hot water heater? You plumb the hot water to your bathroom through that, or? Yeah. Okay. Very good. Thank you.
Yep. And so then, you if you empty that 2 gallons of hot water, which would be hard in a bathroom sink, if you did, then the hot water that's coming in, you would still have some hot water basically, because after 2 gallons, no doubt you would have run enough hot water from the tank. You'd think at least that you would actually have the tank, the heat pump tank hot water. But yeah, you run the hot water through it, and then you have your instant hot water, and it's cheap and easy. Yeah, like these little things. This is mine right here. This Bosch 2.5 gallon. This is literally what I have to my left right now, and you can see it's a couple $100. 2.5 gallons.
So there's the solution for the person who was asking that question. Just put that very close to your sink, and then you have hot water in a couple of seconds.
So exactly. Now, Joanne Panone, she has a question. It's different. She says, my 12-year-old ground source heat pump, she says geothermal water furnace, which is same thing as that. Water furnace is a brand. Geothermal is another way of saying ground source heat pump. My 12-year-old geothermal water furnace brand must be switched from cold to hot. These heat pumps don't, ? And I think what you're referring to is an air source heat pump. Because your ground source heat pump, apparently you have to tell it what season it is.
Right. I have links, hoses under the ground with the
ground source, the geo source.
Right.
So having to tell it whether or not to do heating or cooling is something that I see is necessary for air source heat pumps today, where on the thermostat, you'll say heating mode or cooling mode. And that's kind of all you have to do is just tell it if you want it to be in heating mode or cooling mode. Is yours harder to do than that?
Yes, I have to go down and switch the water furnace itself from one mode to the other. It also has 2 big hot water tanks, one's storage and one's preheat. So I'm looking, maybe I can get rid of those tanks.
Yes. I think that 12 years ago was before there were computers that were built into air source heat pumps. And it's really important to know is that computers changed heat pumps radically. So when you put in your ground source heat pump in 2011, there wasn't really a choice for you to use an air source heat pump in your climate and have it work as a
Right.
heat. You did the right thing. You did the best you could. Today, there's just tons and tons of products that will work far below freezing, down to -30 Fahrenheit, that are air source heat pumps, not your geosource or ground source heat pump. So all you really need to do is just have a box outside that has a fan inside of it and just collects the heat that way, as opposed to collecting the heat from the ground. And yeah, it would be simpler. For your next heat pump, if you keep all your duct work, or if you have are you using the water to heat like radiators or heat a floor?
Geothermal, radiant heat in the floor.
Okay, yeah, you can use an air
Yeah,
source.
water. Yeah.
Yeah, so that's your next one. When you're ready, just get an air source heat pump and it'll be air to water. And I'm going to show you what brands that you might want to consider. For other people who have hydronic systems, this will be relevant. This will be relevant to you. If you're doing so, Space Pack. The image of this. This is one sec. Where's the space? Oh, okay. This is what it looks like. See this? It's got 2 fans. Like each of those circles represents a fan, and that is an air to water heat pump. It's for heating the water in your house. This is a big one. It's called 5 tons, and we were talking earlier about how 3 tons is what most houses need, especially
Right.
efficiency. But yeah, it would look like this. And if it doesn't look like a double fan one, Chiltrex, the CF50, here we go, images. See how this has got a double fan? Same idea. This one is smaller and it's got a single fan versus double. And this is just how much heat energy can it collect? 1 fan does less than 2 fans. So the bigger the heat pump, the more fans you find on them.
I only have a 1,400 square foot home, a rancher, well
You should-
insulated.
Use this single one here. That would mean I think you need 2 tons for your 1,400 square foot well insulated house, and a Chiltrex is about the smallest that they make. They make those 2-ton ones, 24,000 BTUs, and that's what you need.
Thank you.
Chiltrex. It'll cost a couple $2,000-3,000, and then you'd stick it where the ground source heat pump is outside. Like there's a device that is the heat pump somewhere, and you just put that thing there, so it's using all the same plumbing and the same electricity, and you know,
Everything's inside. The air conditioner's in the attic and the heat pump's down in the cellar. My water
Well-
furnace is in the cellar.
this needs air. So you're going to need to put this outside of your cellar and
Okay.
run either refrigerant down to where your plumbing is, or run hot water, depending. Just so you know, because it needs air in order to find heat.
So this uses air and it won't use my geothermal coolant?
Correct.
Right, okay.
Yeah. And these only, something to know about these is that if you have radiators, we don't in the United States have a heat pump that works well with radiators. They're all over in Europe, and they get to use propane as a refrigerant. In the United States, this is a movement that we have right now because propane is actually really good for the environment. It has almost no global warming potential if it gets leaked. It has great thermal properties. It goes up to 160 degrees Fahrenheit, which is what we want for radiators. We don't have it in the United States because of political corruption from UL. There's a little stamp at the bottom of most appliances that says UL, and they accepted money from the refrigerant industry to ban propane because I'm not joking. This is true. They accepted money so that we don't get to have more than 16 ounces of propane in heat pumps in the United States, which is only enough for like a window heat pump. They did that. In the rest of Europe, we can do other things. So let's say that you had radiators in your house and you wanted to go to a heat pump. I want to show you what you would use instead. So Yaga, Jaga, Yaga makes efficient convectors. Efficient convectors, more about this technology. So they're designed for heat pumps. Come on. It's not going where I want it to go. Come on. let's try it this way. Products. Anyway, they've got a radiators. That's all I got to say. If you were looking to have a heat pump, and heat pumps generally only go to 130 degrees Fahrenheit, and radiators want 160 degree Fahrenheit water, and you're like, oh no, I have all these radiators in my house, and I like the way radiators are. I would like to keep radiant heat. And I would say, okay, then go to Yaga, and they make efficient convectors. Here we go. Finally, efficient convectors. In these images, you're seeing sort of white things at the bottom. These are all different types of radiators. They have a whole bunch of different looks to them. Like
Right.
build into the wall, knock on wood, which is a wooden looking radiator, and they have white ones that are metal and such. These are, you'd have to replace the radiators in your house if that's what you wanted to do. But then you could use a 130 degree Fahrenheit or colder air source heat pump water heater, or for that matter, ground source. None of them get above 130 Fahrenheit until you get to propane as a refrigerant, which I said again is really only available over in Eurasia. And it's like in the papers today and such, they're trying to get it available in the United States because it's such an important thing for having everything we need to electrify every house with no drama. Because, you know, replacing radiators is a little bit of drama.
Well, I can see it's because of the gas.
What do you mean?
Propane is gas. Propane comes from
Yes.
fracking, so I can see where the root cause is.
Yeah, the concern that they said is that because it could catch on fire, that they didn't want to have it in heat pumps. But
Oh,
tell why that wasn't truthful, because the refrigerant that's in heat pumps now is also flammable. It's basically another fossil fuel. That's the stuff they're using that boils at really cold temperatures. And we all have propane tanks in our lives. Like people
right.
can't 5-gallon tanks of propane, and they have 200-gallon tanks of propane in their homes. Having a gallon or two of heat pump of propane in a heat pump is not nearly as dangerous. So that's why I was like, you know, and it was clear they had accepted money. That's not me making that up. That is a well-known industry fact. UL went private and they accepted money.
Mm.
Mm.
Thank you.
You're welcome. Stephen Flynn, you asked, or Stephen, is there any difference in the effect of hard water on a heat pump water heater? No. It's bad for all water heaters. You know, you soften your water so you don't have mineralization that builds up in the pipes. On demand, either electric or gas, have smaller pipes and they get mineralized faster. So a tank type heat pump water heater is better for mineralization than any kind of on demand, but it's not better than a gas water heater or an electric resistance water heater. They're all essentially the same in the problems.
Thank you.
Resistance water heater, the anode inside of it can also get more mineralization, so I'll take that back. A heat pump water heater is no particular issue.
Mhm.
Pump water heater is a good idea. Stephen, did you want to say something?
No, just thank you. I've seen the massive amount of on the anode. I think it was the anode because you couldn't get it out of the. I caught myself just trying to yank it out of the darn water heater, and I'm trying to figure out a throughput of money with the, you know, related to the cost of these things over time. You know, how many do I have to replace? So that's all my mentality here.
You know, the good news is that the heat pump water heater that's just a heat pump that I'm suggesting.
Mm-hmm.
Let me show you that again here. Share screen. Okay. The Rheem ProTerra plug-in heat pump, 120 volt. That one doesn't have an anode in it. The lack of an anode means there's nothing that can get mineralized.
Mm-hmm.
How this works is that water flows into the tank, and wrapped around the tank, not inside of it, touching the water, wrapped around the tank is the refrigerant coil that heats up the tank.
Oh.
So you don't have something inside that's hot that then is collecting lots of minerals on it. So it will be better. But this is not the hybrid, right? If you have a hybrid, that means you have an electric resistance tank also, and then it has the anode. This is the heat pump only model. And this is the one that you'd put into a room that stayed above 37 degrees Fahrenheit. so that it always worked. But that would avoid your mineralization problem.
Thank you.
You're welcome. It's a good, interesting question, to be honest. Now, let's see. There's more questions here we're running through. Oh, Kristen had to go. Yeah, drop off your daughter for bed. I hope she communicates with us again in the future. Tom, was there any interesting questions you wanted to address? There was a whole bunch here that I haven't even seen yet.
Well, yeah, there have been interesting questions in here. We've been talking about propane. One question was about the absorbance band of propane and methane, and what happens with methane. It's a chemical that its molecule is 1 carbon and 4 hydrogens, CH4, and it just gets up in the atmosphere and it plugs a little band in the atmosphere where the Earth is using it to radiate the Earth's heat to try to stay in this comfortable climate we've had for 10,000 years. And it's funny, CH4, funny for it, just happens to plug that hole and jam up our ability to cool ourselves, like sealing shut our window. And that is going to probably melt the methane hydrates that are undersea and then free all that methane from the hydrates and from the tundra. And so I like to say methane has a plan for Earth and it's Venus.
No, I understand the chemistry of methane. So you're saying that the methane, because propane's heavier than methane.
I couldn't find it in the little refrigerant table I was looking at, but propane's formula is C3H8, and it's heavier than air, and it drops, and it's a coincidence the GWP is 3. Well, there's 3 carbons. I think it drops and it oxidizes into 3 CO2s, and that's why. Or no, it must be different because it's on a by weight basis. Anyway, I'm not positive why methane's got.
No, I mean, I'm just I'm not an analytical chemist, but I just would have guessed propane would have a similar absorbance spectrum to methane. But
no, it all has to do with the frequency that they vibrate at, and so we've got the radiation going through, and methane is such a simple chemical; it can vibrate at a nice high frequency. Is my theory on it, and then C3H8 is a big bulky chemical, and it's not going to be able to vibrate it that way. So it's going to get passed by that infrared radiation.
So a couple things more about propane. One is that because it's heavy, it sinks. It's heavier than air, my understanding, I've read that concrete will actually absorb propane, and there's a fire hazard there. And then the other question is, so it only takes a gallon or two of a refrigerant to fill a typical residential heat pump system. Is that all is required?
It takes it takes about 2 gallons per ton. So 12,000 BTUs, right? So it's about 2 gallons per ton is my understanding of how propane works. And you might have for then like 6 gallons for the entire system that's running through your house, right? But sometimes they make them as package systems, and then you can reduce the amount of propane that's used in it because you're not circulating it through a loop.
Through far distances. Package units all together.
So I appreciate it's a relatively small quantity of gas. Thank you.
Yeah, there's a question from Holly Pollinger that I thought was interesting. She says, what if you don't want or want an air conditioner? You just want to replace your gas furnace with a heat pump. And as you pointed out, Tom, you don't have to use the air conditioner, but for better or worse, heat pumps are always set up to do heating and cooling. Well, almost always, not on those tank water heaters. In those cases, they're literally just designed to do heating only. But all the ones for space heating your house, they are exclusively bi-directional. So they'll do cooling in the summer or heating in the winter, and they always can do both, and you don't have to use them. But they are there as a function. It's just how it is. And I'll say this, like I'm in one of the coldest summertime temperature climates in the United States. And this part of California is intensely cold next to the ocean. There's a current, I could just go on it, but it basically is super cold. We'd say it's like 65 degrees Fahrenheit all summer long here. But one day it got hot up to about 80, and my mom, who lives next door, she didn't know she had an air conditioner function to her heat pump, but she got super white, like she was having a heat stroke, kind of bad situation because it was too hot outside for what she was used to. And I had to rush her in and turn on the air conditioner and just sit her down in front of it to cool off. And it was one was like, I didn't know I had an air conditioner. It's like, yeah, you don't have to use it, but it's nice to have one every once in a while, just in case.
Wow.
'Cause not getting younger, and no one gets, like, everyone just gets a little bit worse as they age at controlling their temperature inside.
Well, also, we've entered climate roulette where everyone gets somebody else's weather.
Yeah, sooner or later you're gonna get something crazy. Carol Geisander, you asked, what about when the furnace is currently in the basement, common, and there are 2 air conditioning units at different spots in the attic, one in the main part and one in the addition? Where would this all go? And I think the way you do this, and there's a lot of different ways to skin a cat, right? I think the way that you do this is that you take out the air conditioners, and in the same spots where you have the fan coils for the air conditioners up in the attic, that's where you'd put the heat pumps, and they would use the same duct work. And as provided that that works for you, you're like, the air conditioner only serves half the house, Sean. Oh, I didn't know that. But assuming that your air conditioner actually serves every room with ductwork, then you could just put the heat pumps where the air conditioners are. Does that sound right, Tom? Do you have any thoughts on that? Well, you're muted.
No, I just mentioned I'd need to see pictures to try to understand what she's got, but I usually picture the main air handler being down where the furnace is, and then I'd need to see a little more about what she's got. She may be talking about having package units on the roof that maybe are doing air conditioning and or heating. And so anyway, before giving a definitive answer, I'd need to know more.
I'd like to interrupt. The people are dropping off. Some people want to stay probably for all the questions. They can stay on if you're willing.
I want to take on one more question. I don't know if Benaz is still here. Is he or she still here? Let me look at that. Benaz, are you still hanging around? Yes, you are. Okay, Benaz, this is for you, buddy. So you asked, we got 2 estimates for the heat pump of our house in Montclair. We were told by both that we needed both a furnace and a heat pump to make sure we were warm in the winter. Is that correct? No, that is a way to double the price of your installation. And it's not at all correct. What you do is you get a cold climate heat pump. And the idea that you'd add a gas furnace is just some crazy gas engineer's idea about how to make more money. But instead you get a good heat pump that works in the wintertime. And you might say, well, which one? So for the folks who are still here, you can see on my website here, redwoodenergy.research, which I'm putting into the chat for anyone who needs to, everyone in the meeting here, you can see here's the chat. This guide here, a guide to retrofitting your single family home. You open it up and it has a table of contents. In a table of contents, it includes heating, ventilation, air conditioning, space heating. I'm going to zoom in on this so you can see it easier. Okay, and there's all these different kinds of heat pumps here. Ground source being one on the far right hand side. I showed you the Chiltrex, the hydronic, all these different kinds of heat pumps. What you want to have, I think, is the Carrier. Carrier is kind of one of our best right now doing cold climates, but Daikin, York, these are all great products. And they look just like this, and they can do their full performance at cold temperatures, and you don't need to put a gas furnace in. You just need to get the cold climate versions of them. And that is the answer to the question, is like, just get a cold climate one. And this booklet, I think, is perhaps one of the most helpful things I could send you all away with, because it has all the products I've been showing you and a lot of explanatory language. So like if you wanted to see stoves, look, here's a whole bunch of induction stoves and slide-in ranges and antique looking ones. Sort of like, Everything is in here. It's supposed to be a pocket guide, like the way that you get a pocket guide for identifying birds in the field or things like that. This is to help you understand what's out there. And so this is the page for your central ducted heat pumps. So, and to your question, Banaz, if you would like to email Tom and I, or the person who organized this, Steve, if you email us your bids, we'll write back to you with comments and suggestions to try to help you figure out how to not get hosed by people who are putting in the wrong system. Okay, so yeah, we're at the end. And I'm trying to make sure that you all know that you can email us. I'm going to put my email address in the chat, pm@gmail.com. I can usually respond within 1 week of getting an email because I have a lot of other work. But Tom, could you put your email address in there? Tom is semi-retired, so he's in a different situation than me. Lucky dude. Like his kids are grown up, mine are still in the house, all that kind of thing.
Thank you, Sean and Tom. That was great. Thank you for your hard work in putting together tonight's show. I wanted to put a plug in. Our next show will be October 19th. We've been busy planning actually the next 3 months of monthly webinars. And then we're returning back to our standard third Thursday of each month and at 7 p.m. A trick is that you can use the same reservation URL. Even before I advertise the next webinar, you can sign up for the next one. For the change of pace, we have one or two participants on October 19th as they move toward achieving magical transformations toward fully electric. And also waiting in the wings will be a talk on IRA. We can size to whatever time is available. So thank you for joining us tonight. I think this was great. A lot of Q&A. We'll send out material, the Q&A and recording and slides shortly in email to all those people who registered. So thank you very much for joining us tonight.
Thanks, y'all. Have a nice evening. You take care.
Thanks. It was great. Really, really enjoyed it. Thank you so much. Very